All right, today we're going to learn about specific heat capacity. So, as you've been doing your experiments on heat transfer and conduction, you found that some types of materials don't transfer heat as well as others, as we discovered that the cardboard acts more as an insulator and some of the metal objects act more as conductors. And we're going to figure out why that is by learning about specific heat capacity. So, what is specific heat capacity? It's the amount of heat that must be supplied to increase the temperature by 1 degree Celsius for a mass of 1 kilogram of the substance. And the international unit for this is joules per kilogram per degree Celsius. And the formula that you're going to need to write down on your notes that measures specific heat is as follows. Q, which is the amount of heat that's necessary to heat the object, equals mass of the sample times the specific heat of the sample, C, times delta T, which stands for the change in temperature over time. So once again, the amount of heat that's necessary is equal to the mass of the object times the specific heat of that object times the change in temperature. So different materials have different specific heat capacities. And if you look at the heat capacity of aluminum, its specific heat capacity is 897 joules per kilogram Kelvin. Whereas if we look at water, water has a heat capacity of 4,181 joules per kilogram Kelvin. So one of the big reasons why we have this huge difference is when we look at the chemical bonds that are happening between these different atoms. And in water, we have some strong covalent bonds that exist between the oxygen and the hydrogen atoms, but we also have what are called hydrogen bonds, which are slightly looser bonds that exist between the electrical negative forces that exist between the oxygen and hydrogens of adjacent water molecules. And because of those bonds, water can absorb a lot of heat before it's actually going to change temperature. So when we apply this concept, think about when we were using the Bunsen burners, or excuse me, the sterno containers the other day, and we were trying to increase the temperature of water to get it to boil. Um, a beaker of water is going to take a lot more energy than it will take for a similar mass of substance of iron to be heated. And that's once again because it has a bigger heat capacity, and so it's going to more slowly increase in temperature. Whereas iron has a lower heat capacity, which is a faster increase in temperature. So when we're applying this to your solar ovens, as well as cooking utensils, we're going to look at what types of materials might be best for increasing temperature quickly in your oven. So if we look at a pot and pan, oftentimes pots have copper bases because they have a low specific heat capacity, and the pot can become very hot very quickly. And so this enables quick conduction of heat from the flame to the pot. But oftentimes when you're using the cooking utensils, usually you're going to have something with a plastic handle or a wooden handle. And those materials have high specific heat capacities. And we want to use things like that we're actually touching so that the food doesn't become too hot and the heat isn't absorbed so we don't burn ourselves. Plastic, as well as cardboard and paper, are poor heat conductors, and they also serve as insulators. So when you're wanting to try to trap that heat in your solar oven, it's a good idea to surround your device or surround your whatever cooking vessel that you're using with a series of insulators so that you can concentrate that heat. And oftentimes pots and pans have a metal body to surround the food, again, because they have a low specific heat capacity, so that the heat can penetrate all of the different food in your pot. So another application of specific heat differences and tying together conduction and convection all together is the sea breeze. So when we look at the specific heat of land compared to water, I want you to think for a moment. Which do you think has a higher heat capacity, the ocean or the land? All right, well, if you guessed that the water has a higher heat capacity than the land, you were right. Basically, what happens is just like we talked about earlier, water has a high specific heat capacity. So, as the sun is heating both the land and the land will heat up faster than the ocean. Well, as that happens, hot air is going to rise due to convection currents. So, as the hot air rises, because hot air is less dense, it will go up higher in the atmosphere. And then once it's higher in the atmosphere, it will start to cool down. And that cool air will start to descend over the ocean. And then again, that air will get sucked up above the land because of that hot heat from the sun and the convection current there. So this is an example of convection. This is an example of convection at work. And this drives all of our different air currents and ocean currents globally. So that ties this all together. So now I'm going to have you go back to your solar ovens and apply what you've learned and consider the different materials that you're going to be using. You're also going to be doing a series of practice problems that we'll solve together in class